Hello and welcome. In this video, we will talk about the data processing instructions and do a couple of examples. So data processing is simply another way of saying we'll talk about the arithmetic and logical instructions. There's nothing fancy about it. So let's go ahead and get started. I showed you in the previous video that we can point to a data location in memory and then grab a word or a byte from that memory location into one of our registers. So let's go ahead and actually manipulate this data a little bit. So one way, for example, some of these instructions are, you have the add and subtract, the very basic instructions. You have add, subtract, multiply, divide. You have shift as well. But let's do one. Let's do an add instruction. So how does the add work? Add takes, let's keep it simple again. Add takes three parameters. Let's say it takes the destination, the source, and some value. Okay, you can also, for this value, you can also use another register. So in this example, this is kind of interesting. Basically, add R1 to itself and store it back into R1. You can, to keep it simple, let's do R2. So the destination register is R2, and then the first register is R1. I don't want to use a second register. Rather, I want to add a value, like an immediate value into this R1. So let's say I will add the immediate value of 3 into R1. Then this instruction essentially reads R2 equals to R1 plus 3. And that's it. If you want to subtract, subtraction works just the same way. It will take 3 parameters, right? So it takes the destination register, so R3. It takes the first parameter, and then it takes, let's say, an immediate value. Again, you can, instead of using an immediate value, you can use like whatever register you want. You can have 2 registers for your operands here. But let's say I'm going to subtract the value 1 from R1 and then store the results into R3. So this means R3 is equal to R1 minus 1. I'll add the notes here. This is basically R0 points to X. Then this one is going to load a word from that location into R1. Okay, pretty straightforward, really. Excuse me. Another data processing instruction is a shift. So let's see if we can do a logical shift. So logical shift left shifts the data to the left in your register. So similar to these data processing other instructions that we did, logical shift left takes the destination register, a source register, and the amount of shifting you want to do. So let's say I want to shift by 4. Essentially, shift all bits of R1 by 4 to the left, or to the left by 4. Okay, so basically the content of R1 will be shifted left by 4 bits. Okay, there is other variations to these instructions as well. We'll talk about the conditions later, which apply to some of these instructions, and then but for now, what I wanted to show you, just to kind of wrap it up, I wanted to show you how we can store the data back into memory. Now that we brought it from memory, we did some modifications to it. I want to store it back into memory, and the answer is really simple. All I can do is, all I have to do is use the str, which stands for store. Pretty simple, right? And similar to LDR, you can store, use the str, which will store a word into memory. You can use strb to store a byte into memory. There's also half word as well, but we're not going to talk about that now. But okay, so let's store R2, for example, into this address that's being pointed to by R1. So essentially what we're doing here is we're pointing to that memory location. We're grabbing a word from that memory location and store that into R1, and we are manipulating this word in different ways. Okay, so let me remove this from here. I'm going to store that into the memory after each of these instructions. So I'm going to store the content of R2 in this case into that memory location. And notice that I did not override the value in my R1, so I'm continuing my work with the original value that I loaded from that memory location. Then I'm going to store that word after I subtracted 1 from it. So I'm going to use strr3 into memory location that's pointed to by R0. And then the last one is I'm going to strr4. I'm going to store the value that I got into R4. I'm going to store the value that I have in R4 into the same location. So if you take a look at the memory, we're going to see this as the first value that's being stored. After we grab it, we're going to add 3 to it and then store it. So this goes up by 3. And then we're going to subtract 1 from the same original value, store it back into memory, and then shift the content by 3, or shift this value by 4, sorry, to the left, and store it again into memory. So let's see how that looks. Again, this is my disassembly, but I'm actually more interested in the content in the memory, and then I'll keep track of these values here in my register. Okay. So it looks like this is my first value, right? FF00 ABCD, FF00 ABCD. So it should, if I execute the first instruction, the pointer should be pointing to this location, and then I'll grab it and I put it into R1. So here we go. Okay, that looks good. This is FF00 ABCD. Good. The next instruction that I will execute will add 3 to that content and store it into R2. And if you add 3 to that location, let's see, CD, CE, CF, D0, D1. Oh, D0, sorry, D0. So FF00 ABCD plus 3 is FF00 AB D0. And then I'm going to store that value back into memory. So I should see this value being overwritten right now. Here we go. It copied the content from R2 into this location in memory. Good. The next instruction is going to subtract 1 from that value, from the original value. So ABCD minus 1 is ABCE. And then I'm going to store this one back into memory. Okay. Oh, wait a second. What did I do? Oh, I subtracted -1, so essentially I added 1. So okay. Let's just do this way. Okay. Again, no change, no change. And then here we go. I added, or I subtracted 1 and I stored it back into memory. So now I have that value stored. Not yet. Step over. Okay, here we go. CC. That makes more sense. Yes. CDE, right? Not the other way around. So I will see this being stored into memory. Here we go. And then the next one is a shift. So notice that that value, this one that's stored in R1, has its content shifted left by 4. So what happens? This F will get dropped out. This first F will be dropped out of the value because we're shifting the content to the left by 4 bits. F is 1111 in binary, so these 4 ones will get dropped out, and then 4 zeros will be inserted to the right of that content, right? To the right of that value, and 4 zeros in binary equal to a 0 in hex. So this content is simply this content shifted left 4 times to the left. Okay, so now we will write this value back into memory. Here we go. Okay, so so far so good. We were able to grab a word from that memory location and then kind of manipulate it a little bit and store it back into memory. Like I said, there is a way to navigate this memory locations 1 at a time, 4 at a time, and so forth. You can check out some of the other videos if you like. But what I want to show you is maybe something a little bit cooler, I guess. So let's say I have my message here. It's a label, and it's an ASCII Z. Let's just say the word hello. Okay, so let's see if we can convert some of these characters from lowercase into uppercase. So what we've done here was pretty cool, but maybe you were like, do I really care about moving these values into registers, manipulate them, and store them back into memory? Maybe, I don't know. But maybe if I show you that you can change the values of these strings, that will make a little bit more sense to you. So let's do this example, but in this case, we'll work with bytes, right? Instead of working with words, because the string is a bunch of characters back to back, and each character is 1 byte. So I will repeat the same thing. Now I'm going to point to message instead of X, and I'm going to use, like I said, I'm going to work with bytes. So instead of message, instead of X, I'm going to refer or point to message. This points to MSG. Right? You can call that label whatever you want, by the way. And here I'm going to load a byte into R0. And what I want to do is I want to convert this H from lowercase into uppercase. So if I run this right now and I step through it, this is the address of my message. And this is 68 hex, which is the ASCII or the hex value of ASCII lowercase h. So if I want to upgrade it into uppercase h, I need to know the value that I have to make this to make it uppercase h, and then I want to write it back into memory. So to do that, let me look at the ASCII table, and you can look up any ASCII table you want online. They'll have the same values. So in this case, the letter h right here, lowercase, has the hex value 68, which is the one we have in our register. And then the uppercase h has the value of 48 hex. All these values are in hex. So if I go back to my emulator or simulator, technically, if I can subtract from R1, so R1, the hex value 20, I'm going to be able to convert this lowercase h into an uppercase h, right? So subtract 20 hex, which is equivalent to the ASCII value of uppercase. And then I'm going to store it in memory. Remember, we're working with bytes, so I'm not going to use str by itself. I'm going to use strb, which means store a byte from this register into this location in memory. Let's see if this works. And if I step over, oh, yeah, it's working. Oh, did I click on step out? I don't know. Okay. Step over. This is the address. Loading a byte. This is my 68 right here. Add if equal. And let me see here. I think this is executing the older code. Yeah. Oh, I remember. I forgot to put the hashtag. Okay. Here we go. Get the address of that string, load a byte into R1. It's already there, so there's no highlight. I'm going to subtract 20 from it, so it came down to 48 from 68. Then I'm going to store it back into memory. So I clicked on the memory tab, step over, here's my capital H instead of my lower h. And if I want to do the next character, all I have to do is I have to add R0, hashtag 1. Do the same thing. Load a byte from that location, subtract 20 from it, and store it back into memory. So this is going to do the same thing for the next character that I have in my string. So if I step over these instructions, I will see that this lowercase h is going to be converted into an uppercase h. Here we go. And then this e should also be converted into an uppercase e. And this will, you can repeat this multiple times. This is obviously not the most efficient way to do this, but I wanted to show you that you can grab some values from memory, manipulate them, and store them back into memory. In summary, we went over a few instructions here that allows us to manipulate the data in our registers and store them back into memory. Like I said, there is a lot more about these instructions. You can go in depth about load store, the shift instructions and whatnot. You can look them up online. You can go and read a little bit about them in the ARM manual. Or you can, there are a few pop-up links on the top right corner in the video that will take you to some of the videos that talk about these instructions in details. But for now, I wanted to show you, like I said, that you can grab a value from memory, make sure that you're working with the correct striding, right? So if you're working with words, make sure that you're loading a word, and then when you advance the pointer, you advance it by a value of 4. If you're working with bytes, make sure you load a byte, store a byte, and then you advance the pointer also by that amount. Again, one more time, there is situations where you need to manipulate some of these bits, but that's a different discussion. Like sometimes you need to grab the entire word and then you can concatenate values and whatnot, but that's a different discussion. Anyway, this is it for this video. I hope you learned a few things here. We'll talk about some conditioning, conditional execution and branching in the next videos. But for now, thank you for watching, and I'll see you in the next video.